Hey, hi everyone. First of all, good morning and thanks for coming. This is our 10th meetup. So we are doing for last 3 years now and we are trying to doing for every quarter and this is our 10th meetup and thanks for coming everyone. So yeah, today I'm going to speak about MariaDB and what is new in MariaDB. So MariaDB has recently released this my 10.6 like 10 days ago, to be honest. Yeah. So we will see about what is there and what is something to be learned about in MariaDB 10.6. Yeah. This is me, Karthik. I have around 11 years of experience working with MySQL. Yeah, I used to work with Yahoo before starting my DBOps, and I used to speak on various conferences and write some blogs occasionally. And yeah, I founded my DBOps 5 years ago. Yeah, cool. So about my DBOps, so we are into open source support. Database supports top open source databases like Postgres, MySQL, and MongoDB. And we were founded in 2016 as a small MySQL shop with a 4-member team, I would say. And now we are close to 50 members. And in the last 5 years, like we have assisted over 500 plus customers. And we are also achieving multiple things. And we were one of the partner of AWS for the database specialization. And also we are a PCA certified organization. So coming to our services, we do the database consulting services and the managed services where we take care of our customers and the clients. Databases, to be honest, might be on premises, on cloud, which involves AWS, GCP, or Azure, or anything. And we cover all the three databases with a unique set of teams for MySQL, Mongo, and the Postgres. Yeah, these are one of the few customers. Few unicorns are there in this list, and this map shows the graphical distribution of the where our customers are located. Yeah. So let's get into the agenda. So the today's agenda is what is MariaDB doing in the open source ecosystem, and what is new, what's the features released in 10.6, and what are the variables added, and is there some variables got removed by this because these are essentially needed for a DBA. Yeah. So general audiences, of course, DBAs, database engineers, DBREs, cloud DBAs, DevOps engineers who like to handle the databases by themselves. Yeah. So let's see what is MariaDB doing in the open source environment. Of course, MariaDB is a open source RDBMS. It's a fork of MySQL, as you all know. So Monty has started this MariaDB and it started as a fork. But is it still a fork? No, it's not just still a fork because it has deviated a lot. Like it is no more a drop-in replacement for MySQL. There is a huge number of changes operationally and even the internal queries also. And of course, it is one of the top 10 RDBMS. Like it ranks 8 in the DB engine ranking if you look at the RDBMS ranking. But if you look at the overall ranking, it comes to 12. It is a humongous growth, I would say. As a small company, just grown along. And they have their own set of products also, which are mostly under GPL license or might be a DSL license or even their own proprietary thing. So which includes MariaDB server, we all know, and MaxScale, BSL license again, still we can use it. MariaDB column store, it's a GPL one and we can use it. And they have their proprietary engine like MariaDB Expand, which is a distributed SQL. So each has its own purposes. Okay, yeah. So MariaDB releases, how frequent the MariaDB servers are getting released. So I just took it from the web. So what I can observe is every 1 year, right, there is a major release. Like in the 10 series, every 1 year, they have some major release like based on the past history. Okay. Yeah. So MariaDB 10.6, what is that? Yeah. So if you look at MariaDB 10.6, of course, the initial release was made in April 2021. And they had a couple more releases like 10.1 and 10.2, and 10.3 becomes the GA in 6th July. It means exactly 10 days ago or 11 days ago. Yeah. So what does this? So what does the 10.6 brings to the table? Yeah. So 10.6 has multiple features. And most importantly, like as a DBA, when you work in an organization, You should be aware of the latest MySQL or the MariaDB releases or your latest software and what is the feature in it. Because these features, right, they can help you to scale your application or your workload better and better. So that's the prime reason. So if you look at MariaDB, right? Yeah. So MariaDB 10.6, they have the features like atomic DDL'S, which is there in 10.6, and skip locks. Skip lock is another feature which is there in MySQL, but it is recently added here in the MariaDB. And then they also support the modern SQL function SQL offset and fetch, JSON table, and ignored indexes, and they have ported the schema, and few improvements in the InnoDB and the replication. Yeah, let's go one by one. So what is atomic DDL? So atomic DDLs, yeah. So 10.6 has the atomic DDLs, or you can consider as the crash safe DDLs. What it means is, right, example, you are making alter a alter table or a create table on any engine, not only specific to InnoDB, any engine. You make a alter, the DB system get crashed. So what happens? You might leave some orphaned tables or this temporary tables or FRM files. Yeah, MariaDB still has the FRM files. They haven't adapted a serialized data dictionary as in MySQL, so still they have the FRM files for the even for the InnoDB engine. So there can be a state they can be orphaned there. So this atomic DDS, right? They try to overcome it. So how they overcome it? Actually, they have a log called DDL log. There is a log file which records the DDLs. Okay. And they also say that the DDL should be atomic in the sense it should be all or nothing. Like only when test completed, it should get written to the bin log also. So they are tracked. These changes, these alters are tracked in the DDL log file. And there is a variable that is called log DDL recovery. So this is just to change the path of the log file. By default, it is located in the data directory. But if you are sure, like it can be moved to a different location and it can be persisted. Okay, you can move it to a different location. Like the error log file people used to move it out of the data directory. Yeah, you can do the same here. So yeah, I tried to simulate the same. So we created a sysbench workload. The table name is sbtest, and we try to create the index. So when you try to create the index, right, this is what recorded in the DDL recovery log. So if you observe closely, right, you can see this is the InnoDB engine. That's why they call the InnoDB, and they have the SQL alter, the 7FF, whatever, and it's InnoDB engine on sbtest database, and sbtest is a table name. And the given alter query is a create index query. So this is just recorded. So when the DB goes for a crash, all right, when it goes for a crash, a new log file is generated, which is called the backup log. So they just try to compare, like what is the alter, is it complete or it should be rolled back. So they recover the structure back. So that's how it is implemented, and it's called DDL log recovery. Of course, still there are some loopholes. They are still not perfect. You can read a lot about in the MariaDB Jira, which is more deep and more vivid than when comparing to the documentation or whatever. They have more detailed insights in the Jiras also. Yeah. And the next important feature is a skip locked and skip no waits. Yeah. This is there. This is already there in MySQL 8.0, and now MariaDB has ported it with their own implementation on InnoDB. So where it can be applied. Example, you have a high hot table. Mostly people use a select for update, and they are updating a log table or a very hot table. So what happens at cases, right? Like the queries will get wait to occur the log. The reads, right? The select for update, they try to get an exclusive log and they have to wait. So it will be in a high concurrent machine or a very high concurrent workload, this can bring down the server. So what happens? MySQL is all the same with the skip locked here also. There are two units. One is the skip locked and other is the NOWAIT. Let me share you some examples. Yeah. So this is a very simple simple example. I created a table with only one row sorry, only one column, that is I, and then I have inserted a sequential number of inserts, 1, 2, 3. And then in session 1, I try to lock the row 2. I is equal to 2, and for update, I'm trying to lock it. So what happens in a general scenario is, if the transaction is not committed, the other transaction will wait to acquire the lock. But let us see how it is solved in the skip locked. So in skip locked, yeah, now here I am trying a new transaction. I am trying for a select for, I am trying to update the whole table. Select star from T and for update. But I'm using a skip lock where I am ignoring the locked records. Make sense? I'm not ignoring, instead of waiting for the lock for the entire table, I'm just ignoring the number of rows which are locked. Some applications still work with that. So yeah. And there is one more thing that is called NOWAIT. What if I am waiting for a lock? What happens in a real-time scenarios? You will wait until your lock wait timeout, which is a 50 seconds, and then it says, yeah, you have reached a lock wait time, and then the transaction rollbacks, and you have to wait for 50 seconds. And your application can't wait that much time. Of course, you can say that no wait. So it triggers an error immediately. Okay, I'm not able to get the lock. So better you can roll back the transaction. So this is called no wait. Okay, I'm not ready to wait to get the lock. Either you can just throw a error. That's what the no wait means. Skip lock means that you can skip the records which are locked. Yeah. So SQL offset and fetch. Yeah, this is another SQL variant. If you look at the other RDBMS and MySQL or MariaDB, right, we are a bit lagging in the more SQL support. But of course, MySQL 8 and MariaDB latest version, right, they have covered a lot, like the window function or CTEs or lateral iterate tables, those kind of stuff. And still, this SQL offset and fetch, this is more like what to say, that limit. You can say this order by and limit, right? It is more conjunction used with that. So there are two keywords. One is the offset and other is the fetch. Where the offset shows, okay, in a table where I have to start the record from. How many records I have to skip it. How many records I have to skip it, like instead of limit m, right? Limit m, n. We just give the m as the start and the n as the end point. So the start point is fetched here. Like what is the offset it should has to be. Okay, that's what the offset, that is the starting point. So here I have given an image, I have numbers, of course I have mentioned 8 twice here for a purpose, I will explain later. Yeah, I have numbers from 1 to 11 with 18 twice. And fetch, and the fetch shows that where I have to start from. Like offset is like skipping the records, how many records you want to skip from the start. And offset is like how many rows I have to skip, fetch further from the start point. Okay, it's like the how many rows you have to read it. And there is one more thing called only and with ties. So only is like it will give the next 3 records or 4 records what is given the fetch. But with ties, right, it will give the duplicate values also, or the values which are equivalent and which comes within the range. Example, right, in this case, yeah, I have a table in the side below. You can see we have numbers, say, yeah, 5, 6, 7, and 8 twice. If I give 4 records from 5, it should bring only 5, 6, 7, 8 with only. But if I give with the ties, right, it will print the 8 twice. Okay, let us see how it works, the fetch and offset, in the next slide. Yeah. So fetch, offset fetch, yeah, I am ignoring the 3 rows. Yeah, offset 3 rows, it ignores the first 3 rows and starts from 4. Okay, and the second one I'm using the fetch and also the offset and the fetch. So here I ignore only the first 2 rows and fetching the next 4 rows, and I'm using a only option here, so the duplicates can be avoided. And the important thing is, when you use the fetch, always there should be a order by. The order by should be mentioned. Yeah. Ignored indexes. Obviously, this is kind of new to MariaDB, but not new to MySQL. So ignored indexes. So MySQL had a feature like invisible index, where you can create a index and you can mark it as invisible, or you can make the existing indexes invisible. it works the both way, right? And there's an optimized switch to control it. But MariaDB has ported this feature, like, but they have their own way of implementing stuff. So what they call it is the ignored index. It means, yeah, index can be ignored by the optimizer. So optimizer don't see it, even though the index present it. The optimizer don't see it in the execution plan. So how it is implemented? So it is like we have a keyword like ignored. So you have to add the keyword ignored to a query. Like whenever we are creating an index, right? If we add the keyword as ignored, so what happens? The index become the metadata change happens at the backend. It's not the entire table rebuild. It is just a metadata change. So this won't be visible by the optimizer. And this is really helpful in this case, like when dropping the index. So yeah, because in MySQL we have an option like we can make the existing index or even create a new index as invisible, and we can slowly add it to the database. Like it's other way around. You can create the index and test it with the optimizer switch and then add it. But here they don't have a switch, but still it's helpful in the dropping the index. Like example, you want to drop a unused index. Of course, MariaDB has performance schema now from 10.5. They have ported the 5.7 performance schema. Previously, they have the 5.6 performance schema. So that can help here. So what happens is when you're dropping the unused index, right? The index might not be still used, but those statistics are taken into the calculation by the optimizer. So optimizer has a brain, right? So it have the more number of stats as much as can, so that it can give the predict better plan. So it shows that, okay, even though the index is not used, right? Sometimes it uses stats to show that, okay, this is the right index based on other suggestions, right? It says that, okay, I'm not using the index because I have the stats from the collections, right? So it shows that. So that's the reason, right? Even dropping an index, right, it should be safer, because creating an index is a pain because you have to rebuild the entire table. Yeah. So you can mark it as ignored. You can just give a iter query and mark it as ignored and wait for a couple of days and check if there is any performance impact, might be your scheduled job or whatever, and then we can drop it. That's what it's all about. So I have tried it with a employee database. I have just created a ignored index. So this is a commonly available data. Like this table has only two columns. One is the department number and name, and department number is the primary key, and the department name is the unique key here. So I have made the unique key as a ignore, or which is not invisible. So we can see from the next execution plan, like it is going for all, which means a full table scan, and it has to go for a full scan. And even if you look at the extra condition, instead of using index, right, of course, the first one is reading from the index record. The department number is out of as a primary key, but in the second case, right, it is just filtering it. So yeah, so the index is made, ignore, and of course later I can drop it if I wish. And it won't take time because it's just a metadata change. So schema, yeah. As I said before, right, 10.5, they have adopted the 5.7 performance schema. Now in 10.6, the schema is completely ported here. Of course, the schema is just a view on top of the performance schema and the other internal tables. So now we have it. So this can helpful in identifying and troubleshooting all the database related issues, most of the database related issues, and collecting the queries and stuffs. Okay. And also they have ported a couple of tables from performance schema for the replication. So MySQL replication, right, previously it was single threaded. Now the parallel replication has come a longer way. Okay, even MariaDB has their own way of implementing the parallel replication. The applier threads. So always the slowness is at the SQL layer, that is a SQL thread, not the IO thread. So the appliers and their status are now monitored via these tables. So these tables are ported, the applier tables are ported from performance schema 5.7 to here. Previously they were not ported. Now it is ported and they are merged here for the instrumentation and the better analysis. Okay. So InnoDB. So yeah. So if you look at history of MariaDB, right, they have done lots of changes in the InnoDB. They have a good number of developers on InnoDB, and they have made huge number of changes, which adds more benefit to the InnoDB. And sometimes they might be controversial. Example, like the way of MariaDB implementing and MySQL will be completely different. The performance variables, example, right? the buffer pool instances is taken away in MariaDB, but MySQL is there, and they say it improves the performance. And this benchmark says they won't. They have their own way of justifications, which is completely internal. Okay, yeah. So in this case, what the improvement had is right. If you observe the last release, the 10.5, even the InnoDB log file is single file. It's no more two files. You will have only a single file instead of two files. The default is a two, and we try to increase it, but yeah, but from the 10.5 it is only a single file. So they find that the single file gives more performance in the two files. Okay, now in this case, right, the improvements made is the bulk insert. Like when someone is creating a new table and trying to load the data into it, and this is the first time they are loading it, so it means the table is empty and it should not have an undo log view, right? It doesn't need a what to say, undo log. Okay, so what they have for the bulk instances are initial data loading. Now what they do is, right, they made a single undo log, or we call it as a empty undo log, which is much optimized, so that the performance get improves. Instead of tracking undo log, right, they are improving in such a way. So there is a very big Jira for it. And the second thing is the row format is compressed, which is becoming read only. Like uh, there is a variable also they have added, like to override this feature, but the compressed format is going away by default, right? Like the barcode has two formats, one is dynamic and compressed, but they are trying to retain only the dynamic, and the compressed going away, and they have the complete compressed based on the zlib and the other functions, which is a internal feature. Now they are trying to move it away slowly. By 10.7, right, this compressed, now it is read only. By 10.7 it should be going away. So they have given the reason also, like they have implemented this feature in 2005 in 5.0. It was written by Mark McCullough. Like uh, it was not as performance as before. Like with the modern accessories, right? The compression ratio is also not good to the compressed format. Example, it compresses up to 9 KB. The 16 KB pages becomes 9 KB. So it's not a great compression, and still it has to rely on the 3 disk blocks instead of the 2 or whatever. So they are trying to go with the different methods. So it is becoming read only. And the other thing is that temporary table space. So temporary table space, of course, they should not be written back to the disk or made in the buffer pool flush list. So it is also taken away. And there are many variables got depreciated. Like it's not like newly depreciated. Like they already implemented the plan in 10.5 and the before releases. Now they are completely taken away. I have given a couple of examples like NoDB page cleaners and buffer pool instance, but I have a complete list at the end of the slide. Yeah. Now the next thing is the replication. In the replication, there are a couple of small changes. One is the master host. Now they support up to 255 character length. Yeah, it makes sense with the modern servers on cloud, the host names and the endpoints becomes huge. So it's no more IPs, right? The host names are mostly the endpoints or the names or the DNS naming conventions. So it is good to have a better or a names of better length. So it makes sense. And the second thing is the expire log days. It is added now, but it doesn't support. Still now it doesn't support the Galera clusters. Like they are trying to work on it. There are a couple of open Jiras for it, but it is newly ported also. Previously it was only days. My MySQL already has the expire log days. Sorry, expire log seconds. Now it is also ported here. And Galera WSR mode. PXE has something called a strict mode when it comes to clustering. Now MariaDB has implemented something like that. It's called WSR mode, which allows the, you can say, standard format, like okay, all the tables should require the primary key, or you can allow the tables without primary key. And this MySam and ARIA are the experimental features in Galera, like for replication, because Galera supports only InnoDB, but of course there are experimental releases like MySam and ARIA. MySam for a very longer time, and ARIA is based on the MySam, right? So of course it can support ARIA also. Now, yeah, if you want to allow the MySam tables to get replicated, we can enable these kind of modes. Or if you want a strict mode, of course there is strict mode also. Depreciations, of course, couple of depreciations. TokuDB. TokuDB is no more supported by MariaDB, like the engine support is taken away. Of course, MariaDB supports multiple plugins. So TokuDB is taken away, not because it was stopped by the upstream. So here the upstream is the Percona. Percona has stopped supporting TokuDB in favor of RocksDB. TokuDB is a product of Percona. and they got stopped it because RocksDB gives a better compression stuffs. So the fractal tree injection is going away, and the LSM and the RocksDB is coming in. Okay, and Cassandra, there was a plugin for Cassandra read write, but it is non-functional, and MariaDB has stopped its development long away, so they have depreciated it in the 10.6. And this is a huge list of variables which got depreciated. If you look, the background scrubs, of course, this was implemented only in MariaDB, and they have taken it away. And the buffer pool instances, it's taken away. And the file format, it makes sense because now we support only the one file format, like the barcode. There is no more Antelope support, even MySQL 8 or MariaDB. So it's a good thing to take away. And large prefix, yeah, large prefix was needed when it was a 767 length. Now it's really good. All are in the barcode format, so large prefix is taken away. And the log schedule algorithms and log checksums, now they have different way of implementing log files in group. Previously we have it, right? Like you try to dictate how many InnoDB log files should be there. But MariaDB has taken away already in 10.5. They are going with a single log file. So this doesn't make sense, right? The log files in group doesn't make sense. So it is depreciated. And many other variables like the scrub log and scrub log speed, these are a part of it. And also the page cleaners. Okay, yeah. And by this, we almost come to the end of the session. Yeah, let us have some questions.
Thank you, Karthik.
Yeah,
So I believe one of the panelists today is having a question. Over to you, Mugees. You can post your question.
Yeah, can you go to the previous slide? I have some questions related to the variables they have deprecated.
yeah.
I'm curious, why would they go for deprecating the buffer pool instances and ignore the the uh, thread concurrency as well?
Yeah, makes sense. Yeah. So they have their own reasons. If you look at it, right? That's what I told you. They have the core InnoDB developers, which were there even before MySQL existed. To be honest, they have a couple of core InnoDB developers. One is Mark Makilo. So based on their benchmarking, right, they feel like instead of splitting the buffer pool into multiple instances and maintaining their own flush list, right, it is better to have a single one. And so it's taken away.
Okay. Thread
Okay.
concurrency, they don't want to control a thread concurrency, like
Yeah, thread
let it
concurrency and concurrency tickets and everything. Yeah.
let the server
Yeah.
to the peak. Huh?
Yeah. They have their own way of controlling. Yeah. That's right. So even right, MariaDB has taken a very huge step when it comes to InnoDB. Like they have previously they were using extra DB in the first releases or the, and then they have moved out and they started using the vanilla InnoDB and made some multiple optimizations on top of it. Okay. So that's why I told if you look at the files and everything, it will be a completely different one.
Sure.
It's not a drop-in replacement. So even their way of encryption stuff is completely different. So that's the reason the Maria backup comes into picture and stuff like that. Yeah.
Oh, sure.
Thank you, Karthik, and thank you, Mugees. Let's wait for another couple of minutes for more questions from our participants. Okay, thank you once again, Karthik, for another astounding session. Let me pass on the baton to Subit Shah to go for the exit. Thank you.
Thank you, Karthik, for an insightful and enlightening session. A session without questions is a session wasted. Here's our email address to which you can write an email with your questions, and we will be able to answer all relevant questions as early as possible. We are excited to be live soon. Relevant updates will be shared on our official page. For more details, please follow us on LinkedIn, Facebook, Twitter, and Meetup page to get more insights on our blogs, stories, and events. Now that we have come to the end of 10th Open Source Database Meetup. On that note, I'm happy to announce that our next meetup will be held on the month of October 2021. Till then, have a great year ahead and a great day. Thank you.